tower footing resistance measurement. So I am Vishal Patil, product specialist for this tower footing resistance meter, which we are providing from our channel partner Megabras and Tentec. And along with me, Mr. Nilere, lead product specialist, is also available. So today,
Good afternoon, everyone.
Today we will discuss majorly on what is earthing, its importance, different types of earthings. Then we will see what is mean by soil resistivity, its different measurement methods. And after that, we will see our instrument TM25r, which is the tower footing resistance meter, which is based on the high frequency earth resistance measurement principle. So we will see in detail, and at the last we will have a question and answer session. So first we will see what is earthing. So we all know that earthing is mainly used to provide a path to whatever the faulty current or the leakage current flowing from any electrical equipment. So it must be provided a ground or a perfect ground so that that leakage current will flow through the earth, and the user or the operator may not get any electrical shock. So to ensure that this protection to the user, and also the whenever the fault is occurred on any electrical equipment, then this fault current or the faulty voltage, whatever is there, that must be grounded at the time of fault event. So that's why a earthing system is very important for any electrical installation. So uh, generally, as I said, it is mainly used for a personal safety, then protection of equipments, and it also ensures the reliability of any power system. Okay, so next we will see what is an earth pit. So earth pit, it is an construction such that a earthing rod or any type of earthing plate is uh, inserted into the ground to provide a path to a faulty current. So generally these earth pits are designed to reduce the ground resistance, because a earth pit is an assembly of different types of components are also added in the earth pits, so that the effective earth or the grounding resistance should be reduced below, we can say that ideally below 1 ohm. So whenever the fault will occur, the current will flow from the power system through this earth, uh, towards the earth through these earth pits. Now we will see what are the different types of earthings. So first one is the plate earthing, in which we can see here uh, there are the certain depths are predefined for this type of plate earthings. And in this type of plate earthings, generally the uh, copper plates are used for the copper plates are used for this earthing purpose. And in this type of plate earthing, generally charcoal or the nowadays the special chemical compounds are used to ensure to increase the reliability of this type of earthings. So this type of charcoal and other compounds, what they will do, they will effectively reduce the grounding resistance. So this is the first type, which is plate earthing. Next is the pipe earthing. So instead of copper plates, generally hollow pipes are used in this type of earthing. And this type of pipe earthing, whenever if we can say that if we use the solid rods, then that type of earthing is called as a rod type of earthing. The next one is the strip earthing. So generally this type of copper strips are used where the rocky surface or the hilly surface is available at the substation or the any plant or the nearby any equipment, then this type of earth surface we require this type of copper strips, uh, because the whatever the area required for that rod or pipe earthing is that type of digging or the earth contact with this metal conductor is not possible. So that's why we will use this type of earth strips, and these type of earth strips are bended at a 90 degree, so that the maximum earth contact will be provided to the metal conductor. Next one is the mat earthing. So number of earth strips are connected in a mat form, and this type of all these metal strips are connected to the all earth pits, so that there is a complete loop will be formed, and the whatever the leakage current is flowing through this type of earthings, this leakage current will be shared by this type of different earth pits by using this mat type of earthing. Then next we will see the what are the different factors affecting on the earthing pits. So generally, uh, the earthing pits performance is affected by the water table variations. Means let us consider whenever in uh, summer season the water levels are not that much, because the whatever the earth surface nearby the earth pits is having very less moisture content in it. So due to that, what happens, the earth resistance is varied due to the lower moisture ingress in the soil. And in rainy seasons the water tables or the water levels are increased in the soil, so that's why the effective earth resistance will be reduced. So this type of depends upon the different seasons. The water table variations causes the change in the uh, performance of the earth pits. Then the next is the if the grounding conductors or the plate type of rods or the plate rods or the pipes, this type of earthing conductors are got corroded, then due to that the effective earthing resistance will be hampered, and due to that the earthing pit performance will be uh, hampered by this type of corrosion. Then the next is the contamination in soil, or the if the this type of problems generally occurred in the chemical or the oil industries, and this due to this type of other other components such as chemicals, oils, or the different types of acid, this contamination on the soil or the surrounding of the conductor, this will also impact on the earth pit performance. And the next one is the mechanical integrity. Any loose connections or the of this type of earth mats or the earth conductors, due to that also the earth pit performance will be hampered. Next is the electrical integrity, and the last one is the improper maintenance of the earth pit. So if we are not maintaining the earth resistance properly in our whatever the maintenance schedule is planned, so if we are not checking and maintaining the earth resistance whatever is the allowed in that in every organization, so if we are not maintaining that earth resistance values, then this type of improper maintenance of earth pit will also hamper the performance of the earth pits. Next one, now what is the soil resistivity? So the soil resistivity is nothing but a resistance. Let us consider if it is a earth surface around which we want to know the what is the soil resistivity. So let us consider a cylinder of a earth having a cross section area of 1 square meter and a length of 1 meter. So this type of a earth cylinder which is having this cross section and a length, particular length. So for that particular cylinder, what is the exactly resistance is available? So this resistance value is called as a soil resistivity, and soil resistivity is expressed in ohm meters, and it is denoted by symbol rho. So this soil resistivity, what it will define? So it will define how well the soil can conduct the electrical currents whenever it is uh, connected to any electrical equipment. So this soil resistivity measurement will helps us to choose the different location, different types of electrodes or the earth networks before building to any. Let us consider the construction of any substation or any electrical equipment or any plant. So uh, this soil resistivity survey will helps us to choose the proper locations for the earth electrodes or the earth bits. Then the next, it will also helps us to design the electrical specifications of earth electrodes and earth networks. And also it will optimize the construction cost for the earthing networks. So now this while measuring the soil resistivity, it is advisable to uh, bury the earth electrode as deep as possible, because let us consider if we are inserting this earth electrode to a 50 centimeter depth, then what happens if we pour the water around it, then what happens due to this influence of water ingress, the soil resistivity may get changed. But if we insert these earth electrodes as deep as let us consider as 3 meters, then what happens, this moisture ingress will not be that much effective at this very high depth. So that's why it is advisable to bury the earth electrodes as deep as possible whenever we are conducting this soil resistivity survey. So this is all about regarding the soil resistivity. Now, these are the some values which are used for the different types of land types or the soil types. So these values are given in various IEEE standards. So we are just giving you the some figures of resistivity for different types of terrains. So we can say that for marshland type of a terrain, the resistivity is generally below 30 ohm per meter, and also it can goes up to the 1500 or 3000 for the earth surface where the stones or the sandstones type of surface is there. Then the soil resistivity may go higher above the 1500 also. So these are the some values mentioned for the depending upon the earth type. Then the next, why this earthing measurement or the earth resistance measurement is required? Because it is the one of the basic prerequisite for ensuring the safety of the operator or the because if there is any leakage current flowing through the any electrical equipment's body, then any user may get in contact with the electrical equipment, then due to that what happens, it may he gets a shock, severe shock. So to avoid this type of electrical accidents, so it is very important to measure the earthing systems or the earthing resistance periodically. Then if there is any no earthing or grounding electrode, so it is a very dangerous for any people. Then the next one is the regular inspections are required, because the earthing resistance may get vary due to the various parameters we have seen, which we had seen in the previous slide. That is the corrosion or the any type of environmental parameters. So we have to always monitor this earthing resistance periodically to ensure the user safety. Now we will see what are the different measurement methods for the earth resistance and earth resistivity measurements. So first one is the stakeless or the clamp-on type of measurement, in which a current clamp or clamp-on type of receiver is used to measure the earth leakage. So this clamp-on type of measurement can be also done without disconnecting the grounding wire. In this type of measurement, we will use the we will measure the whatever the leakage current flowing through the earthing system itself. We will not inject any particular signal, so we will just measure the leakage current, and accordingly we will measure the earth resistance. And the next method is the clamp-on measurement, in which we will inject a particular voltage of at a certain frequency, so that uh, there is a potential difference will be formed, and due to that a current will flow through that earth path, and we will measure this current with the help of another receiver, and we will calculate the earth resistance. So this is called as a stackless or the clamp-on type of measurement. The next one is the one pole or the one stack method. So in which two sub methods are there: 62% variant method and phase to phase earth loop measurement method. So we will see these methods in upcoming slides. And the next one is the two pole stack measurement or the equilateral triangle measurement. We will also see in next slides. Then the most popular methods, which is the 3-pole and 4-pole measurements, which are widely used for the earth resistance measurement, we will also see in the next slide. Then for the earth resistivity measurement, the two methods are widely used, which uses the 4 electrodes for its measurement. The first method is the Venus method, and the another one is the Scummler method. So these two methods are depending upon the they are generally varies in the uh, distance between the 4 stacks. So based on this distance between 4 stacks, different formulas are used for the earth resistivity measurement. So as per IEEE standard 81, we all heard that the follow potential method. So as per IEEE standard 81, the follow potential method or the 3-point earth resistance method is most effective and accurate method for measuring any type of earth resistivity, ground impedance, or the earth surface potential any grounding system. So we will also see all these methods in upcoming slides. So first we will see clamp-on or the stackless measurement method. So in this clamp-on type of method, this is a quick and easy way to measure the grounding resistance, but it is but here there are some limitations of this method. So uh, generally, now first we will see how this measurement is takes place. So in this measurement, we will apply the known voltage of a certain frequency uh, into the grounding connection via a transmitter coil or a voltage generator, and the leakage current will be measured through a receiver coil or a separate coil is used for the measurement of leakage current. So based on these two uh, voltage and current values, the if earthing resistance is measured or the calculated. So this generally this clamp-on type of method requires a complete resistance path. A complete resistance path means all these elements which are present in the loop are measured in the series, and also due to that, this type of clamp-on method is only effective whenever there is a complete grounding circuit is present. We cannot use this clamp-on method to a grounding system where it is not connected, or a incomplete grounding path. We cannot use this clamp-on method. So the four major limitations of clamp-on type of method is that it will be effective only in situations with multiple grounds in parallel. Uh, Also, this type of clamp-on methods cannot be used for the isolated grounds, as I said earlier. Then it cannot be used for the alternate lower resistance returns, which are not involving the soil. So we cannot use this type of clamp-on method. Then the next one is the this clamp-on methods. These results are actually accepted on faith, because since this clamp-on type of measurement includes the uh, other elements which are present in that loop, so that's why we cannot say this method or the results are accurate. They are accurate for these only some specified conditions like multiple grounds in parallel. So the return paths which are involving the soil. So this type of limitations for this type of clamp-on method, and this clamp-on method is not that much accurate as we can say that the stake type of methods, or the in which we are using the practical grounding rods for the measurement. So this clamp-on method is very poor, and these results are only must be accepted on the next method is the single stake method, or the 62% variant method. So in this single stake method, only one auxiliary stake S is used for the uh, earth resistance measurement. So in this method, as in this connection diagram, we can see that the S terminal is used. Uh, 1 minute. So in this diagram, we can see that this auxiliary spike S is used for the only one auxiliary spike is used, and this existing H tech means whatever the earthings of the instrument is available, that it will act as a H techs for the measurement of the earthing resistance, and the phase earth conductor will be act as a E tech for the measurement. So this by using this two existing earthing connection as two stakes, we will we can we can perform the measurement with the help of one auxiliary stake. So in this method, only one point you have to keep in mind, that this distance between S and E is the 62% of distance between uh, H and E. So that's why it is called as a 62% variant method. Now, why this distance between these two, between this auxiliary rod and this E stake is 62% of that distance between HE? Because uh, by performing different trials and various experiments, this 62% distance, or the 62% method is formed, and these are also available in the different standards, because this 62% distance is referred as the neutral for zero reference earth zone. So there might not be any influence of this in the measurement due to this type of rod placement. So this is the 62% variant method by using single stack. Then the next one is the phase to phase earth loop measurement method using single stack. So in urban environments, means we can say that there is we cannot you insert these earthing spikes, or the whatever the earth rods, we cannot insert at the time of measurement if there is any limitations of space or the concreted areas, then we cannot insert the earth spike. So in this type of uh, practical problems, we can also use this method, this single stack method, using phase to phasor loop measurement method. So in this method, uh, generally we will use the earth and internal resistance of the test object and the capable resistance, and for that we will use an RCD clamp for the measurement. So uh, generally this uh, me- method is giving the value which is the R measured value is greater than the whatever the exact earth resistance, because there might be some uh, earthing of that existing system may come into the picture. So this is the limitation of this method. Then the next one is the two stake or the triangular measurement method. So in this measurement method, we will require two electrodes. First one is the earth electrode, which is being tested, called as E, and the we will require the two measurements by using stake S and stake H. So first we will measure the earth resistance between terminal E and S, and uh, After that, we will measure the earth resistance between E and H, and these E, S, and H, these 3 points must be placed such that there is an a triangle or the equilateral triangle is formed. So by meeting these conditions, we will measure these two earth resistance values, and if there is these two earth resistance values between ES and EH are differing from each other at a very high margin, then we have to change the position of S from the first position, and we have to change this S pole, and again we have to repeat the measurement. If same problem, then again increase the distance and again repeat. So by uh, doing this type of repetitive, or the we can say that uh, the manual interference is required in this type of two-step method. So this method is having very good accuracy, but as it is a trial and error method, so this is not that much used in the practical scenarios. So that's why the three-pole measurement method is developed and it is widely used. So in this three-pole measurement method, a current generator which will generate the current pulses in a at a certain frequency. So this current generator will inject an alternating current I with the help of its generator, and generally for this three-pole measurement method, the earth electrode to be tested will be connected to the E terminal of the instrument. Then H terminal, or the current spike or the current electrode is denoted as the H, and this H will be connected after the we can say that at the far end electrode is the electrode, and in between that we will insert the voltage electrode, which is called as a S, and this and with the help of this current generator we will inject the current into the through this H electrode, and we will perform the voltage measurement through the S electrode. So by using the formula RE is equal to V is the voltage difference between E and S, and the whatever the current we are injecting, we will calculate the performance of the we will calculate the earth resistance with the help of three pole measurement method. Now, what is the four pole measurement method? So, four pole measurement method is it works on same principle of three pole measurement method, in which just we will use another terminal E, and this E will be also connected to the earth electrode which is under measurement, and we will inject the current uh, between H electrode and ES, and we will perform the voltage measurement between E and S. So, with the help of this four-wire measurement principle, this four-pole measurement method will give us a better resolution as compared to three-pole measurement method, and this method is widely used in the uh, earth resistance measurement in any power transmission or any distribution companies. Generally, this four-pole measurement method is widely used. Then the next one is the resistivity measurement using Venner's method. So in this soil resistivity measurement, now here we are not connecting any earth electrode. So here we are measuring the soil resistivity, so that to do a survey of soil, so that we can build our earthing network. So to do that soil resistivity survey, we will use this Venner's method for the measurement of soil resistivity. So for that, four electrodes are used. In Venner's method, four electrodes are equally spaced at a distance A, Now let us consider this. There is an generator which is used to inject current I between the far end terminals, that is the E and H, and voltage is measured between terminals S and ES. So in this way, the resistance value is measured on this instrument, and with the help of a simplified formula, rho is equal to 2 pi AR, we will calculate the earth resistivity. So we have to always calculate this earth resistivity. Instrument will only measure the resistance value. So with the help of this, rho is equal to 2 pi AR. This is an simplified formula, and the recommended value of this distance between any two spikes is greater than 4 meter. And generally, the depth of this earth electrodes is h is equal to 3a divided by 4. So that we can say that if the distance between E and ES rod is 5 meter, then it is the 3/4 of 5. So, so in this way, we have to insert these earth electrodes at a depth of h. So with the help of this formula, we can easily calculate the earth resistivity in ohms per meter. Then the next one is this Schlumberger method. So in this method, it is similar to the Wiener's method, but the only the distance between electrodes is changed. So how we will place these electrodes? Let us consider this center point O as a 0 point, and from that we will place the E and H electrodes at a distance d from our zero reference point, and then we will place the ES and S these voltage electrodes uh, at a distance a by 2 from the zero reference point. So with the help of this formula, we can calculate this earth resistivity by using this Schlumberger method. So this is the only difference between the placement of earth electrodes only. So this is the comparison between Wiener's and Schlumberger's method. So Wiener's method is more accurate and reliable as compared to Schlumberger method. Also, the simplified formula to calculate the resistivity, it is a simple calculation as compared to Schlumberger method, but it is a little bit uh, more time consuming, as the distance between the electrodes is very high, and we have to uh, lots of field work is required, and it is a time consuming. Then it is a widely used as compared to Schlumberger method, as it due to its simplified formula and more or the reliable accuracy. And the next one is the Schlumberger method is less accurate as compared to Wiener's method. Generally, this Schlumberger method is used where there are the limitations of the earth, where if we are getting the difficulty to get the soil or the earth surface nearby the, because if there is any concrete type of surface is nearby available, then due to this limitation of the earth surface, we will require this Schlumberger method. Then the next one, only this Schlumberger method, only two outer electrodes need to be moved. So the distance between A is between the middle electrodes is fixed, and only we have to uh, change the outer electrodes distance so that we can get the multiple readings, and we will go for the any conclusion of the earth resistivity measure. Now, what is the test frequency is uh, recommended for these to 3400 hertz can be used. It cannot be, but we have to uh, keep the few things in our mind, that it will not the integer multiple of the system frequency, that is the 50 or the 60 hertz multiple uh, frequency cannot be used. Then generally with the help of Fg is equal to 2n plus 1 divided by 2 into system frequency. So n will be any integer, and Fs is our system frequency, and Fg is the what is the frequency of generator which we are going to use to perform this or the to make the earth resistance meter. So with the help of this formula, any test frequency in between this zone we can use for the earth resistance measurement. Now in earth resistance measurement, we have seen the different methods, what are the different formulas which can be used for the earth resistance calculation. But in case of tower footing resistance, we cannot use the ordinary earth resistance meter to perform the measurement if the guard wire or the guard wire is connected. Means if this transmission line is live or the guard wire is connected to the each of the tower, then we cannot perform this. We cannot use this ordinary earth resistance meter to perform the tower footing resistance measurement. Why? Because this due to this connection of guard wire to the each and every tower, the this adjacent towers may include the parameters or the effect of inductance and capacitance values will be also added in the earth resistance measurement, and due to that we will get an impedance value, and which is not accurate with by using ordinary earth resistance measurement. So that's why we will require a high frequency earth resistance measurement technique. So the model which we are offering, TM25r, is operates on the 25 kilohertz frequency. Now I will explain you why this high frequency is required in tower footing resistance measurement. So in this tower footing resistance measurement, let us consider a signal generator which is injecting the signal or the current of an 25 kilohertz frequency. Now what we will do, we will inject this current between the terminal E and the far end terminal H, and we will measure the voltage difference with the help of voltage electrode. So in this way we will measure this tower footing resistance. So this if we are measuring with this much of high frequency, then we can also with the help of this high frequency we can say that whenever this, let me just turn on the whiteboard. So this whenever we will inject the current, then path will be completed here, and since it is a high frequency signal, so before this current will travel to the multiple paths through the guard wire. So before this influence of these adjacent towers will come, we will completed our measurement with the help of high frequency. So that's why a high frequency source is required for the tower footing resistance measurement. Okay, so with the help of this type of tower footing resistance measurement instrument, we can easily calculate or measure the impedance. We can also measure the tower footing resistance as well as tower footing impedance. Impedance will consist the influence of adjacent towers. Means the inductance and capacitance values can be also measured, and generally the resistance value is calculated with the help of some internal calculations. So this is just an pictorial representation. This is the actual measurement of this tower footing of this particular tower, and these are the multiple paths which are created due to the connection of guard wire between the adjacent towers. So these slides only represents the influence of adjacent tower resistance only. So as if we refer the Segre's article, the Segre WGC 4.2.02 article 275. So in this particular article, this is related to the measurement of tower footing resistance. So in which uh, how this injected current will get drifted through the adjacent tower. So this this topic is discussed in that paper. Now, while using our common earth tester, we will get the earth resistance value in which the influence of other towers means the other towers which are grounded at the different location, that values are also comes into the picture, and due to that what happens, our tower resistance along with the z equivalent. So this z equivalent is consists the effect of adjacent tower. So this impedance will also get calculated in the with the help of the common earth tester. So that's why to reduce this effect of z equivalent in the measurement, we will use this high frequency earth resistance meter. So this high frequency earth resistance method will works on the follow potential method, or we can say that the three pole method, in which generally uh, three poles are used for the earth resistance measurement. Okay. So in this three pole method for the tower footing resistance measurement, we will use this follow potential method, in which the current will be passed through the uh, current will be injected into the in between grounding electrode G, or the tower footing electrode, and the current probe, which is inserted at a 100 meter from the tower footing, actual tower footing, and at the around 60 to 65 meter, we will insert a potential probe to measure the potential difference. So in practice, to generally the 62% distance is used for the tower footing resistance measurement. So at an conclusion, this high frequency measurement is used to with the help of this very high frequency, we can reduce the effect of adjacent towers under measurement. Uh, as I have explained, these connections also. Okay. Okay, so in this tower footing resistance meter, generally four parameters are measured. First one is the R. R is the desired tower footing resistance. So this tower footing resistance is calculated value. Uh, then the next Z impedance. So impedance is the total impedance of this overall electrical system is measured, and this is actually measured, and R is the calculated value. Then the next L is the calculated inductance of the system, and the C is the closest capacitance value due to the adjacent tower. So these four parameters are measured by this tower footing resistance method, and these different Z, L, C values are be stored and refer for the calculation of or the these four values are monitored and referred for the future references for the to measure the degradation of this tower footing over the time, then evaluate the wear and tear of the system, and if there are any bad conditions. So for to analyze this type of different data, we will require these four parameters measured in the tower footing resistance meter. So for that, we are supplying the in India, we are having the our partnership with our Tentec. So Tentec is an Megabrass company's authorized dealer, which is works in USA. So for tower footing resistance meter, we are having the resistance range of 300 ohms. It works on the frequency of 25 kilohertz. Then the maximum amplitude of the current is 25 milliampere. Our kit can give you the result of an accuracy of 2.5% of reading plus minus one digit. It works on the principle of three pole measurement. uh, there are two software connectivity is possible. First one is through PC. Also we can communicate with the kit through the USB port provided on the instrument, and also we can operate our instrument through the Blue Log Android app, so that you can also click the pictures of tower. You can configure the GPS coordinates through the app, and also you can add the voice notes in that app, so that at the time of measurement of each tower, you will have the all the data with you by using our Android app. Also, it is having the inbuilt printer facility, so that by using the inbuilt thermal printer, you can take the printouts of results. So in result, you will get the data of R value, total impedance value, inductance, and capacitance. So these four parameters you can take the printout. So these are the main features of our TM25R tower footing resistance meter instrument. So if you are having any questions, then you can put the questions in chat. So we can answer you. And if you want to send us the technical related queries, then you can contact us on ps@scopetnm.com, or any sales related information you can contact us through marketing@scopetnm.com.